All right. Well, thank you so much, everyone, for joining. We'll go ahead and get started now. A few notes of introduction. This webinar series is just getting off the ground. This is an Alteryx webinar series. Technion is gracious enough to host these, and so we appreciate that very much. We've been doing Tableau webinars for quite a while, but Technion is also partners with Alteryx and Wearscape and Data Robot and Snowflake. So we're excited about all of those partnerships and looking forward to sharing information with the broader communities and ecosystems that exist around those partnerships. So thank you to Technion for hosting this, and definitely if any of you have any data issues that we could help you with, we'd love that opportunity. So this is the Alteryx webinar, and Dina will be presenting. She is our resident Alteryx expert. Actually, we have more than just her, but she is wonderful, and you'll enjoy listening to her. So that is presented. Now those are very interesting images. Those are not what we actually look like, I don't think. But I'll let Dina explain that.
Excellent. Thank you, Josh. I appreciate it. And hi, everyone. I'm Dina Sanchez. And as Josh mentioned, I'm with Technion Data Solutions. I'm a senior consultant there and very happy to be with Technion. As Josh mentioned, we are an Alteryx preferred partner. And I am an Alteryx power user. I've actually been using Alteryx since 2005, even before it was Alteryx, actually. So I've been able to watch it morph and change into the amazing software that it is and that I'm happy to show you today, especially some of the geocoding side of Alteryx. Yes, this image here, I don't usually look like this, although I probably could look like my image a little easier than it takes for Joshua to transform into his image. But since today is May the 4th, for all of those out there who are attending and who are Star Wars fans, we wanted to wish you a happy May the 4th be with you. And we also wanted to have a Star Wars theme today. So my image, as you can see here, is of General Phasma. And yes, although she does make some decisions that may not be the best or nicest decisions, I did choose Phasma because she is actually the first female stormtrooper to be represented on screen. And I actually wanted to show that support for women in the workforce because I have recently launched the Women of Analytics subgroup in the Dallas Alteryx user group. So we now have a Women of Analytics group that people are welcome to join. It is open to everyone, not just women, but open to those who support women in analytics as well. So feel free to check out our blog and our space on the Alteryx community in our Dallas Alteryx user group, and we'll be posting a lot more information about that soon. So I'd like to use Phasma as my image here because I like to think, you know, she's really good at what she does. She is a captain after all. And I like to imagine that if she's using Alteryx, she would probably be really good at it. So that's one of the reasons I chose my image. And Josh, I'd like to ask you about your image for Admiral Thrawn.
Yeah, so Thrawn has been my favorite ever since I read Timothy Zahn's novels, which now are no longer considered canon, but back in the '90s, those were really cool and still very cool. Uh, so Thrawn definitely some aspects of his character I would not want to aspire to, but his strategic and tactical planning are unmatched, and his ability to analyze a situation and understand it. If he had Alteryx, he would be really scary. So probably not the best idea to introduce him to that. But his appreciation of art and the depth of understanding that gives him just a really cool character.
Excellent. I think that's awesome to hear. And I think that fits in well with your handle there of @VizPainter. So Josh is one of our Tableau Zen masters, and he is extremely good at what he does in Tableau, and he is a true artist. So I think this fits in quite well. So now we'll reveal who we really are. So this is what I usually look like most of the time. And I usually do have a map nearby. So as with my image, my degree is in GIS, which is Geographical Information Systems. And I've been using GIS products such as Esri, ESRI, since 1997. So my history of geography and love of maps goes back a long way there. So I definitely want to include that there is always a map nearby. And then this is Joshua's true image.
Yeah, thanks, Dina. So that's how I usually look. Not always holding the sign though, but I am a Tableau Zen master. I love working with Tableau, but I also love Alteryx as well. I am certified in Alteryx, and I love how they work together. So Tableau and Alteryx for years now have had a strong partnership because being able to see the data is great, but being able to shape that data and to include some analytics on the front end just as amazing. And now, as Tableau starts to introduce all kinds of really cool geospatial features, that's wonderful. But a lot of that depends on geocoding the data ahead of time, and so I'm excited about how Alteryx can enable some of that as well. So, Dina, I'll let you take off with what you've got to share.
Okay, excellent. Thank you very much for that wonderful introduction. And again, as Josh mentioned, it all starts with geocoding. So today we're going to go over what is geocoding. And then we'll talk about different aspects of it in Alteryx, such as how you can use CAS, which is the Coding Accuracy Support System from the US Postal Service. This cleans and standardizes your data. CAS does not perform the geocoding, so sometimes that is kind of a misnomer there, where it may be believed that CAS is actually doing the geocoding. CAS is actually just the support system to check the addresses against the US Postal Service and then clean and standardize those, and then it's geocoded with the Alteryx geocoding engine. So we'll go over geocoding in that aspect, and then we'll talk about different levels of geocoding accuracy, and then we'll go into the different tools that we can use, such as Street Geocoder, the US Geocoder macro, Zip9, and even reverse geocoding, along with address parsing. And then I'll show you something very cool about how you can use the Census ID and match that to census block groups. And then at the very end, just to celebrate May the 4th, we will do some ad hoc geocoding. I actually have a message that was sent to me today by my old friend Chewy, and Chewy seems to have found where the Millennium Falcon is being stored, and it's somewhere in the US. So we're going to geocode that, and then we're going to figure out where this Millennium Falcon is stored, and maybe even rescue the Millennium Falcon and take it for a ride. So with that agenda, I'll go ahead and start with geocoding. So what is geocoding? Geocoding is true to its name. It is making a code somewhere along the earth, which is why it's geocoding. So for those of you who may not have really explored latitude and longitude, there is a nice difference between the two. Latitude is really these lines that go across the Earth, and it's measured from the equator, starting at 0, and going north to 90 degrees and south to negative 90 degrees. So with latitude, you're able to find your area going up and down the Earth, really to see if it's a positive degree here going up through the northern hemisphere, or a negative degree going down through the southern hemisphere. And again, this starts at 0 at the equator. And the equator is aptly named because it divides the Earth into equal sides. So a bit of trivia there. And then with longitude, longitude are the long lines, the easy way to remember that go from the North to the South Pole, all the way around the Earth. These start at 0 at the prime meridian, and I'll give you a bit of trivia on that in a moment of why it starts there. And it goes positively from the prime meridian over to the east, all the way to 180 degrees. And then it goes negatively over through the Western Hemisphere, all the way to 180 degrees again. So the reason that the prime meridian starts here, which seems to go right into England here, is because of Greenwich, England, which actually is the source for all of the degrees that start in longitude. One of the main reasons for this is because there was an Englishman who actually discovered the true way of calculating longitude, especially at sea. So it was very difficult to actually do this before he developed his technique. And he actually did it using a very standardized clock that calculate the speed and the direction and distance while you were at sea. So if any of you want to read more about that, there's a book called Longitude by Davis Sorbell, and it describes this man's journey and his accomplishments. He was really an accomplished geographer and mathematician, and it truly changed the world to be able to calculate longitude correctly. So feel free to look up that book. It's also a short movie, also called Longitude. So I highly recommend watching it and seeing how this was actually performed. So longitude is actually taking this point here from the north to the south and calculating in degrees, east to west, and then latitude is from north to south. So when we geocode something, we actually are looking at these degrees, again, starting with 0 through Greenwich, England, and moving east or west. So you may not be able to see these numbers too clearly, but as we go here, this is actually negative longitude because we're going into the Western Hemisphere. And when you look at your longitude and latitude geocodes, once those points are assigned, you'll notice that longitude is negative, at least when you're geocoding here in North America. So for example, in Texas, our longitude is approximately negative 97 degrees if you're around the Dallas area. And then our latitude is actually approximately 33 degrees north for our latitude. So it's a good way to kind of get to know your data when you're geocoding. Take a look at whether your geocodes are positive or negative, depending on where you're geocoding around the world. And again, geocoding is assigning that latitude and longitude and creating a spatial point. So you have your x-axis, which is longitude. So as we go further along the x-axis, we hit each of these longitudinal lines. And then your y-axis is your latitude. So as you go north, your latitude changes and hits each of those lines. So geocoding is more than actually doing latitude and longitude. There's different types of geocoding, and we'll explore that. But what is geocoding when you're actually taking this point and putting it on a map? A lot of people may think that geocoding is actually making a point right on top of your rooftop. So when you enter an address and it geocodes in Alteryx or in other geocoding engines, it's kind of a common thought that this is actually putting a point right on top of your house or right at your front door, for example. And actually geocoding is really more interpolation. So for example, if I have an address, say, between 100 Hickory Street here and 500 Hickory Street here, say I'm looking up an address that might be 250 Hickory Street. To actually geocode, the geocoding engine actually interpolates between these two nodes, which is really a from and a to node along the street segment in GIS, and it accurately places the address at the midpoint here. So it's not actually saying, oh, where is this building and it's at 250, Hickory Street, for example. It's actually simply interpolating between the from node and the to node of the street, which is really the block number of the street. And it's placing that point where it calculates that extrapolated number. So that's really most of geocoding. There are other options for geocoding, and you can actually buy an additional package in Alteryx that geocodes to the parcel level. And I'll show you an example of that in just a moment. But before that, there's street extrapolation. So if you have a range of say 100 to 500 on your Hickory Street here, but someone has given you an address of say 90 Hickory Street, it turns out that's out of range. There's actually not a 90 Hickory Street here. It really starts at 100. And this, knowing this area, since this is actually Denton, Texas, which I went to school at, it actually starts to go in a different count this way. So there's actually not a 90 Hickory Street. So what extrapolation does is it finds the nearest number. So geocoding would actually place it at 100 Hickory Street to kind of find that nearest number to it. And again, that's extrapolation instead of interpolation. So interpolation, as according to the Latin, inter means between. So it's going to be between these numbers. Extra means outside of. So it's going to be outside of the range, and it's going to just find the nearest number to that range. So again, for geocoding according to parcels, there is an add-on data set for that in Alteryx, and it does geocode to the parcel. So you can see here, each of these rectangles represents a parcel of land within a city. And so the geocoding system will actually find the point in the center of the parcel and assign that point there. So sometimes it might be on top of the rooftop, but other times it's just in the center of the parcel. It's actually really finding that centroid to that parcel. And again, not placing it right on the rooftop. So that's really a quick overview of what geocoding is and how it works on a map when you're assigning addresses. So now we're going to go straight to Alteryx. And we're actually going to take in some data and start to clean it with CAS and perform some geocoding. So I'm going to bring in an input data tool in Alteryx, and I'm going to pull in some customer data. So let's see, I've got customers.csv. And you can see here in my preview, I've got a customer ID, I've got store number and a segment, some information here, names and address, city, state, and zip. Pretty straightforward, but we don't have a latitude and longitude. So if I add a browse here, it's not going to create a spatial point and show it on the map. If I did have a spatial point with a latitude and longitude assigned to it or geocoded to it, you would actually see a map in my browse tool. So with this, we need to take our address data and actually geocode and assign that latitude and longitude in order to make that spatial point. First, however, I'm actually going to bring in the CAS tool. So let's see, I'm going to move my thing here for the webinar so I can actually get to my tool sets. So your address tool set, depending on how many other tool data sets you've got open, address is usually between connectors and demographic analysis if you've enabled a lot of your other tool sets. To enable your tool sets, click on this plus sign for Add Remove Tools. And this is actually how you would configure your tool palettes and add additional tool sets to your tool directory. So you can see I've got quite a few enabled here. I like to use as many tools as possible. So if you don't see your address tool set shown, go ahead and click on that plus sign on Add Remove Tools and then enable your address tool set. So here I'm going to click on the address tool set, and today we're going to go into each of these tools, and I'm going to pull in the CAS tool, which again is the Coding Accuracy Support System for the US Postal Service. Alteryx does have one available for Canada as well. So I'm going to bring in CAS. This is going to clean and standardize my addresses. You can actually generate a CAS report from this and actually use it if you have bulk mailings that you need to send to the US Postal Service. And it will actually help you in receiving those discounts for those bulk mailings by stating that your information is already CAS certified. So there are options for that to generate a CAS report if you're using CAS for bulk mailings. So just wanted to add that in there. So you can see with CAS, we've got a lot of options here, company fields, address fields. These are auto-populating, finding the right field, since I do have the data listed with address, city, state, and zip. If you don't have it actually listed, say address is listed as ADDR or line 1 or something like that, you can always use your drop-down and click on the field and actually populate the fields correctly. We also have an option for an urbanization field for Puerto Rico addresses. So if you are geocoding in Puerto Rico, there is that urbanization field that does help you get closer to where that true geocoded address is. For these output fields, I'm actually going to keep the default here. This is just the US default. There is a default for Canada for those Canadian geocoders, but we're going to keep this at the US default, and then we're going to explore what comes out of this after CAS is run. So I'm going to pull in a browse tool here. Go ahead and click run. And again, for those of you who are used to seeing Alteryx, it is blazingly fast. I just cast about 3,000 records, and that was just in a few seconds. So it is one of the reasons I continue to use Alteryx, and it is my favorite software because it does work in virtual memory and really can get speed to insight so quickly by saving so much time with Alteryx. So here I'm going to pull up in the results window a little bit more so you can see the data. These are our results after running it through CAS. Again, I haven't geocoded it yet. I've simply cleaned and standardized my addresses. So I have an address here. I'm going to move this a little bit so I can actually see the screen a little more. So I've got our original address, city, state, and zip. And then CAS is actually going to look that up against the support system for the US Postal Service. And it's going to say what it believes is the suite, the carrier route, the city, some additional information. Last line is where you concatenate the city, state, and zip, including zip +4. It also separated out the +4. And then we'll look at the results. So we've got this AS01 result and so on. The results are very important when you're actually seeing how well it standardized the data. AS01 and AS02 are the highest you can receive, and those are saying that yes, it's found an address, it's clean, it's correct, no changes are needed with AS01 and AS02. AS01 is definitely where it has actually standardized the data and it's fully valid and deliverable for mailing. So if you have a result of AS01, that is CAS certified, and again, is fully valid address there. So some of these, though, have an AE, an AS02, AS17, and so on. Anytime you see AE, it means there was an error somewhere in the original data set that CAS found. So AE09 and AE08 actually signify an error in the suite number. So I'm actually going to click here on row number 3 so we can follow it along. And it shows it's a home office, and it's on Zuni Street in Denver. And AE09 and AE08 mean that there was not a suite number found, but was expected. So it actually didn't find it, and it's simply letting you know that there usually is a suite number associated with this, but it wasn't found in this original data set. AC12, all the ACs mean that there was a change being made. So AC03 usually signifies a city change. AS01 means, yes, it was a valid address, but something was changed with the original data. So if we look here, it's got Lake Circle in Inglewood, Colorado. So CAS found the address according to the zip code and the state and so on, but it noticed that it actually should be Greenwood Village. So with the CAS new address, it actually says that it is in Greenwood Village, Colorado. And so it has cleaned your address. It's actually put it in the right location. And with this AS01, it verifies that it is a valid address for Greenwood Village. So if you'd like to learn more about these result messages, there's a great resource here in Alteryx. You can actually get to this resource by simply clicking on your tool, and this is true for any tools in Alteryx. You can actually simply click on a tool and then click F1. And F1 will take you straight to the tool. So you can actually learn about this tool and learn about the requirements of the CAS tool. For results, we do have results codes here. And as mentioned, AS01 and AS02 are good for geocoding. AS01 is deliverable for the purpose of mailing. And then you get into the different types of results for those AS answers. But then you can get into your error results code. So this is where we can see zip code error, unknown street error. There's those 8 and 9s that I mentioned where it says the suite number is not valid or the suite number is missing, as we saw before. And then you get into change result codes. So this is something that CAS is doing. CAS is actually making this change. And it's adding or correcting, say, for example, zip codes. It's going to correct your state and your city and so on. So it really has a lot of options here. And I highly encourage you to go in, and when you're geocoding and you see this in your CAS output, go ahead and sort and look at these. And this will help you get deeper into your data and understand what was changed and why it was changed. So, for example, AE09, an error that a suite number was expected but missing, that's not really going to change much for you. It'll still find the right location and put it on a map, for example. So these are some of the options with your CAS results. And again, CAS is turning it into this new field of address and city and zip and so on that you can actually use now for geocoding. So now that you've cleaned it with CAS, now you can actually geocode it. Another option I wanted to show with CAS that's sometimes kind of hidden is that CAS has a time zone option. So for any of you who have, say, stores across the entire US, for example, across our 4 or more zip time zones, especially if you include Hawaii there, you can actually check this and it will produce your time zone as an output. So you don't have to get external data or try to match up external time zone data and spatially match it to your points. You can simply use CAS and click on time zone and time zone code, and it will output the correct time zone as well. So it's kind of a little known fact there about CAS, but very helpful. So next, I'm actually going to bring in the Address Toolset, the Street Geocoder. So the Street Geocoder it works in US or Canadian geocoding. And this is just a basic street geocoder. Again, with geocoding, you're finding the latitude and longitude, and it will also create a spatial object for you. So I'm going to bring this in, and you're going to notice my geocoder is TomTom. So that's actually the street network that's behind the scenes in the geocoding engine. And that's the street network that has that from and to node for every street segment that you saw in the PowerPoint deck that I explained earlier. So with geocoding, you have to have a from and a to with the block addresses on it in order for it to interpolate and actually find the address. It doesn't work with simply a street data set, that you've pulled in or downloaded, unless that street data set does have from and to nodes embedded in its data. It has to have certain fields in order for geocoding to work. So that's one reason why Alteryx actually uses TomTom, because it does have that data embedded inside of it, and it runs very efficiently. Another reason it uses TomTom data is that this data is actually part of the spatial data bundle, which is an external or add-on package that you can purchase with Alteryx. And the TomTom data is actually updated every 6 months. So you get a wealth of data, especially for those new streets. And if you're, say, developing or researching in areas of high growth, you'll probably have those new streets in that newest version of TomTom in your most recent vintage. So again, that's one reason I actually use Alteryx as well, is you get really recent and up-to-date data for that TomTom data here. And again, this is the data. It's behind the scenes in the geocoder. So it's running through all of these addresses, and then it's matching them to the streets and interpolating along the streets in order to geocode and assign that latitude and longitude. So for our input field names, it's actually using the CAS ones. You do have the option for your original address, but we're actually going to do the CAS address plus suite as the default. So this is actually found the address number, the street name, and the suite put it all into CAS, where CAS has cleaned and standardized it. You've got your city and your state, and again, all of these have been cleaned and standardized since we're using the CAS fields. And then there's an option here where there's a multiple match, prompt to select. So you can actually say, go ahead and prompt, and you'll see, I'm going to leave this on so you can see what actually happens with that. Or you can say, just return the first one it finds. When it returns the first candidate, it's going to return the one with the highest match score. So you can be very confident that if you do return first candidate, it is probably finding exactly the address that you're looking for when there's a multiple match. So an example of a multiple match is, say, 100 Hickory Street that we saw before. There's actually a 100 East Hickory Street and then a 100 West Hickory Street. If the address is just 100 Hickory Street, a pop-up will happen and say, which one do you prefer? And so you'll actually see this when I run the geocoder. You can use it as prompt to select, and then that will allow you to interactively select which one is the correct address. For these output variables, we're going to have match status and score. It will create a spatial object point, and then a latitude and longitude. We'll get a geo level, and they'll explain more about that after it runs. And then we'll have a census ID. And this is actually really helpful to have this census ID, especially if you're matching to census block groups. You can actually use it to match with the census ID. There's also the MF codes. And so MF is match flag. So it is a flag on whether the street name has changed or the direction has changed or anything like that in the TomTom data. So you'll actually have this match flag that you can check if you are interested to see what has changed in your address data set according to the TomTom data. So now I'm actually going to add a browse tool. And since I'm geocoding and I'm not only creating a latitude and longitude, I'm creating a spatial point. When I run this, it will geocode again, and it'll actually produce a map for me in my browse tool. So here, this is one of the examples of prompt to select. It's going to say which one of these is actually the correct address that I want. So I can do 2855 Adams Street or South Adams Street, and I can choose which one I need. So if I need to, I can just choose this one and click OK. It's going to iterate through and ask me for each one where it's not sure which one is the right address. So it'll show your original address, but it's actually saying, oh, there's not one in the data set for North Lafayette Street. In the data set in TomTom, it only has Lafayette Street or South Lafayette Street. So it's actually going to say, okay, which one do you want out of this one? One thing I can do is just click first to all, and it's just going to click on the first one and select the first one for me on each of these. So again, you saw how quickly that ran. That was a split second there. And now I've got all these spatial points. And if I choose for my base map, my TomTom most recent vintage map, I have a base map here. So you can see, yes, this is Denver, Colorado, and the surrounding area. And these are all my geocoded points. So I can actually scroll through the data. Now we've got the CAS data that we had that was created through the CAS tool. And as we scroll along, we can see now we've got a match status and a score, the spatial object it created, this latitude and longitude that was assigned when it geocoded. And again, your latitudes for North America will be positive, your longitudes will be negative. And then the geo level, for most of these, it'll be street, so it means it found it, well, it interpolated along the street. And then the census ID. So we'll talk more about census ID and what each of these numbers mean, but this is getting down to the actual block level here with the census ID, not just the block group, but actually to the underlying block level for the census data. So we're going to look deeper into this. This match status says exact and score is 100. When it says match status, it doesn't mean it found the address on the top of the roof of the house. It means that for the geo level, which is street here, it found an exact match at the street level. And it will give a score, which is really a confidence level of how quickly or how easily the data match to it, to the street level. So you're always kind of looking for that score of 100%. You might find some that have a lower score. Here's a 93. So there's probably something going on here. As we can see from our codes, something changed. AC12 is a change. There was an error here with the suite number. It did validate it to the O2 level and so on. So it gave it a score of 93 here. So there were a few things that needed to be changed and improved, which lowered that score. But again, match status exact, it doesn't mean it found it exactly on top of the house. It means it has the exact match to the geo level. So I'm going to go deeper into the geo level. But with this next one, I actually want to show a little bit more of a different type of data that we can bring in. So I'm going to bring in another input data tool to the canvas. And for this one, I'm going to bring in some address data. This is going to be address data YXDB. And this data is simple. It's got a company name, address, state, and zip, but it also has a zip 4. So I want to show you how not only to use the street geocoder and look at those status codes, but also use the zip 9 coder as well. So as before, we're going to bring in a street geocoder. And this one, we're not going to clean or standardize with CAS. We've done that earlier. So we're just going to simply geocode the data here. It's defaulting to my input field names, address, city, state, and zip. And then I'm going to add a browse tool and click run. So you can see the data. I'm going to say first to all. Go ahead and just click the first ones on each of these. And click OK. So you can see here, the data are in Massachusetts. So you can kind of see that state outline there of Massachusetts. I'm going to set my base map again to TomTom. And so you can see where those geocoded areas are. So as usual, with the geocoding tool, which is the street geocoder here, we've got our match status, our score. It created the latitude and longitude, correctly coding it. And we've got a geo level. So here, it didn't find the address correctly, but it placed it in the zip code. So there are different geo levels going all the way from actual, which is the parcel, which you can again purchase as an additional data set, from street all the way up to the zip code level. So to see these, I'm actually going to add a summarize tool here. So I just want to summarize on my geo level. I'm going to say, just give me a group by, and then I'm going to say, since Census ID is unique here, I'm going to say, give me a count of Census ID. And I'm going to add a browse to make it easier to see, and then run. So it's going to ask first to all for each of the geocoders that I'm using. You can see here I've got an extrapolation, one that happened here, one that went to the intersection level, one that went to street, and then one that went to the zip code level. So there were, or not one, but 160. So 160 of these addresses went to the zip code level. So when it can't find an address according to street or interpolation or extrapolation, it will assign it to the center of the zip code. So it found it at the zip 5 level. So you have options with these geo levels to really get into these zip codes and say, well, why did it geocode to the zip 5 level? One way to do this is I'm going to actually filter on this. So I'm going to add a filter here. And I'm going to say, filter all of these geo levels that equal zip 5. So we'll say geo level equals zip 5. I want to go a little deeper into these and say, why are those happening? And what's going on with that data? I'm also going to show you a really quick technique here of disabling this very first small workflow I made. So for those of you who haven't seen this, you can actually swipe and highlight and select each of the tools of your previous workflow, and then just right-click and say Add to New Container. So this is the container tool. The container tool is really useful. It contains all of your workflow or parts of your workflow. And the cool thing is you can disable it. So I'm going to click Disabled. And I'm just going to disable that container. And now when I run the workflow, it's not going to run this first one and prompt me to first to all for that geocode, and then the second. It's simply going to run this second one. So I'll be doing that a few more as we build these. And you'll be able to see the container tool and how that works. So I've got first to all, and now I'm exploring these that only geocoded to the zip 5 level. So I've got my geo level here. Again, it says match status exact and a score of 100, but that means it's 100% matched to the zip 5 geo level. So I'm going to look at these addresses and I'm going to say, well, what's making this not find the address? So one of the reasons it does that is it finds a PO box, for example, or the address is not fully listed, or there's no address at all. So it's actually going to revert to the zip code and then place it at the zip code center when it can't actually find the true address. So using this filter on geo level is a good way to go and explore those addresses that are not being geocoded. So as you can see here, there's not a street number here for most of these, just some other information, and that really explains why they're not geocoding. However, for PO boxes, anytime you geocode to a PO box, the zip code is actually the correct zip code for the post office box. So many PO boxes, the post office office's location actually has its own zip code. So whenever you get to geocode for a PO box, if it defaults to the zip code level, that usually is the zip code for that PO box, which is really helpful to know. So now we're looking at this and we're saying, okay, these went down to the zip code level, but there's a few that have a zip 4. So we can actually use the zip 9 coder to get deeper into that detail and geocode to the zip 4 level. The zip 4 level is really useful because zip 4s, that little dash and those 4 digits after your zip code on your mailing address, actually represent 8 to 12 households. It's really that small. It's a very small geography. And again, it's only 8 to 12 households that a zip 4 represents. So if you have data that's geocoding only to the zip code level, and you do have a zip 4 extension or a separate zip 4 feed, you can actually get down to that 8 to 12 household level to a really small geography using this tool here, which is the US zip 9 coder. So I'm going to pull in, and just only for those 160 that geocoded to the zip level, I'm going to say, okay, let's geocode those a little further. So now I'm going to say, what is my zip field in its zip? I've checked +4 is in separate field. If you don't have it in a separate field, if it's all just one number with 9 digits, you can actually uncheck this and just use your zip code field as long as it has those full 9 digits for the zip 9 coder. For this one, I'm going to do zip 4 for my separate field. I wanted to output my census ID, which is down to the block level here. However, for zip codes, it does produce a census ID only to the county if it's a zip 5 level. And then we'll output latitude and longitude, a match code, and so on. And we'll use this to get those other ones that didn't geocode fully down to a nice, smaller geocode level. So now you can see the data. It's really nice. We've got anything for zip 9, as you can see here, is actually going to have some zip 9 information. So we've got a match code here, and a match code is either 5, 7, or 9 for the zip 9 tool. So 5 means it found it to the zip 5 level of those first 5 digits. 7 is the zip 5 level plus the first 2 digits in that +4 extension. So it's actually finding it to that 06, for example, here. And then zip 9 means it found it to all 4 of those additional 4 digits in your zip 9 code. And then you've got record types for what type of zip 9 coding. And again, you can click on your zip 9 coder and hit F1, and you'll go to this Alteryx help. And you can look at your match code and your description. Again, here's 5, 7, and 9 down to the zip level. And then you've got some really deeper information here of what type of record type it is. You've got a firm, a high-rise, a post office, and so on. And so those can be really useful when you're wanting to get deep into your data and figure out what's happening when you do geocoding with your zip 9 coder. over here on the map, I'm actually going to say, let's take off all spatial objects. Those are the basic geocoded objects, and here's my zip9 points. So as you can see, it found quite a lot of them coming off this original data set, filtering for what geocoded to zip5, and now these are the ones that were found with a zip9. So I highly recommend using the zip9 coder. It's very efficient and useful. Another really useful tool, and now that you've seen how street geocoding works and the zip9 geocoding works, and then how you've also seen how CAS works as I enable this container, it's a fantastic tool that actually puts all of these together into one. It's rolled into a macro, and to show you how this one works, I'm actually going to contain these two really quickly so they don't continue to run. And again, you just swipe over your tools, right-click, and add to new container, and then you can disable them. And with that, I'm going to bring in another input data tool, and this will be the address data again. And now I want to actually CAS, and I want to geocode, and I want to do my zip9 coder all in one. And to do that is this great little macro called a US geocoder. So I'm going to bring this in, and you'll see when I add it over to the tools, you've got tabs here. So now you've got your geocoder option, which was your street geocoder. You've got your CAS options here, and it says enable CAS coding. You can uncheck that if you don't want to use CAS, but I highly recommend that you do. We've got a zip9 coder, and then we've got an input tab. So again, you can select your address, city, state, and zip fields. I'm going to say for my geocoder, I want it to be TomTom. Instead of prompting me each time, I'm just going to make it a default, select the first match every time. You've seen these scores and census IDs before. And here, this is where you actually have an add-on that you can purchase for TomTom Multinet address points. And this is where you can buy the address points for the parcel data around the US. So this would actually be where you would get it right to that parcel level, not necessarily rooftop level, but right in the center of the parcel. And again, that is an add-on. For this one, I'm going to keep do not match file, just geocode on this. I'm going to keep all my CAS defaults here and my zip9, and then I've made sure that my input is set up. The really cool thing about this tool is that you can add browses and you'll get your geocoded data here, and then your score and the other information here in your output for the geo level. So I'm going to go ahead and click run. It ran in 2 seconds. And now you can see our geo levels. So actual would be the rooftop data with the multinet address points, which is an add-on. It found about 1,300 for the street. Intersection extrapolates. It geocoded through the zip9 for 36 of them, and then zip5 for 122, and then there were 0 that were not coded. If you click on the geocoded output, you see the very same data, and now you've got all of your information, the carrier route and so on, and your zip9 data, and your latitude and longitude, and your spatial objects. So again, this is everything we just did, all rolled into one tool. It's a fantastic tool to use here. The next thing I'm going to show you is another option, which is the reverse geocoder. So this is actually really cool. If you've ever wondered, you've got a latitude and longitude, but you actually want to find an address, Alteryx actually has an option for that, which is really neat. So they've come out with this option using TomTom's Geocoder API. So this actually reaches out to the API through TomTom and performs the reverse geocoding. So I'm going to pull in an input data tool. I've got a special data set I created that's actually just for reverse geocoding here because it actually has the latitude and longitude only on this. So it's our customer data. I took out the address. We got latitude and longitude. And if you ever get a data set like this, you can use your reverse geocoder. And so with the reverse geocoder, you can have it to where if your latitude and longitude fields are all in one single field where it's separated by a comma, you have an option for that. I'm going to say multiple fields because I have latitude in one field, longitude in another. You can even reverse geocode a spatial object, which is really nice feature there. So I'm going to add all browsers. And then I'm going to run. It's going to think really quickly. It's reaching out to that API through TomTom, and then it's running about 5.7 seconds. And then you can see here, there's my original latitude and longitude. And now here's my address, my street number, street name. It's given me country codes and so on, and a concatenated lat-long output. So what it does is it finds the nearest freeform address number. It's not going to go back and find the actual number right to the rooftop, but it's going to find something really close. So at least with this reverse geocoder, you can get pretty close to that actual address. And it is much better than trying just to find the zip code that it's in, for example, or the nearest city. There's also an option here, and I'm going to actually take this and put it into a new container really quickly. And then I'm going to disable that container so it doesn't keep running and reaching out to that API. There's an option here where you can actually use the address parse. So the address parse tool is really nice. We're actually going to do address data parse here. And sometimes you might get some data where it's got a city, state, and zip all concatenated into one line, and your address is in a separate line. Or you might even get it where it's the full address right here, all in one line. So what do you do with that? Hopefully you won't have to spend a lot of time in Excel cutting and pasting those. Since you have Alteryx, you don't have to do that anymore. So what you can do is go to your address dataset here, or toolset, and pull in a parse address tool. So one way it works is it needs the address separate. So you have to have an address field separate here. And then it's going to look for the last line field. And last line means that your city, state, and zip are concatenated into one. So as long as you have address in one field and your city, state, and zip, even though those are concatenated in one field, as you can see with our original data set here, we scroll over. So as long as we've got address in one field and city, state, and zip in another, then you can actually parse the data. And I'll just run that really quickly. So here's our original data. And then you can see it's casting. So the parse tool is actually a cast tool, and it's using cast to parse those out. And it's finding the zip code and the street name, the number, and so on. So now you can use these individual fields and actually create the city, state, and zip, which is what you originally needed. If it turns out you have a full list here, and in the interest of time, I'll hurry on this part. If you need to actually separate out that full field where your address is concatenated here, you can use a text to columns tool. We're actually going to split that full address. Our delimiter is a comma. I'm going to split it only to 2 columns. I'm going to be, my output root name is full address. It's going to do an address 1 and an address 2. And I'll browse really quickly. So now you can see address 1. Now you've got your address separate, and then you've got that concatenated last line of city, state, and zip ready for geocoding. So again, that's a great feature when you can put all these together. I'll show you very quickly an option here with your census block group data. So let's see if I can get the right one enabled here. And let's see, actually I think I like the one that has the full US address geocoder on this one instead. There we go, get that enabled really quickly. Lots of containers here, which is always a lot of fun. So I'm going to disable that. So now I've got this with my US geocoder. And what I want to do is, there is that option here where it runs. This is reaching out to TomTom on this one. And I'll actually show you with the Census ID. I'm going to disable this really quickly so it doesn't keep reaching out to the API there. You get a Census ID whenever you use a geocoding tool here. So you've got this Census ID. The first 2 digits are the state. The next 3 are the county. The next 6 digits are the tract. And then the last 4 are the block, or the 4-digit block. So the interesting thing is that you can actually bring in your demographic data tool to bring in an allocate input tool here. And since this data is in Massachusetts, I'm going to bring in block groups from Massachusetts. And then I'm actually going to take this data and bring it down to the block level. So I'm going to add a formula after my geocoded tools. I'm going to make a new column, just call it census block group. And then I'm going to use a function of left. So I actually just want the left 12 characters. So the left 12 characters of the census ID are actually going to get me down to the block group level. And this is going to match to the block group that's in the allocate input data set. So now that I've got these two together, I can actually do a join. And I can match the block group here. So with my census ID, with my very new census block group, and I can match it to the key of my block group here. So I'm going to add all browses in the interest of time and just show you really quickly that now you can use that census ID to match to the block groups. So here's my geocoded points, and then here's every block group that those geocoded points are in. So now I've got that spatial object from my allocate input actually matching to each of the block groups. And I was doing it using this really handy census ID field that comes out of your geocoded data. So that's one reason the census ID is really helpful with that. For the very last thing, and as mentioned, I've got this really interesting message from Chewy here. I'm going to open this, and you can see Chewy, he likes to have some fun. So he's given me this, he says, the Millennium Falcon might be at this address. It needs to be output as a KML, which is a keyhole markup language. This is the native language and file type for Google Earth Pro. So what I'm going to do is show you a really quick way of actually inputting this data. So I'm going to bring in a text input tool, and I'm going to do this on the fly. So I'm going to say location, address, city, state, zip. There we go. I'm going to call this Millennium Falcon. Address is 6911 Lemon Avenue, Dallas. And then the zip code here, get the right zip code on there. So I just created on the fly all these fields I need for geocoding. I'm going to take a street geocoder here. It's going to populate with address, city, state, and zip. And then I'm going to add a browse really quickly just to make sure it worked. It says, okay, yeah, it did an exact match it to the street level. So now I'm going to bring it to this output that Chewy's created for me. It says, it's going to be a KML. I think I want my name field to be location. I'm going to use my spatial object just created by geocoding. And I'm going to click run. So that geocoded very quickly. Here in my results, it says, okay, it made this KML at this address. I'm going to click on it. It's going to launch Google Earth Pro. It's going to say my Millennium Falcon somewhere down here. Very interesting. It's somewhere by an airport, judging from this image here. And I'm going to actually click on this. So wonder what this is. Aha, it is the Frontiers of Flight Museum. So for some reason, the Millennium Falcon is being stored at the Frontiers of Flight Museum. So now that we know where it's at, I can go help Chewy rescue my ship, and we can be on our way. So I know we went just a tiny bit over, but I do want to open this up to questions. And again, you can also contact me if you need to through my email here, dsanchez@technionusa.com. We do try to host these Alteryx webinars monthly, so please join us for the next Alteryx webinar, and may the 4th be with you. Again, I'll open it up for questions.
All right, thank you, Dina. We actually have a few questions already, and if anyone has any more, look for that questions panel in the webinar controls, and feel free to type in your question. There are a couple around the different data sets and geocoding options and how that works with the licensing. So specifically the TomTom data set, the CAST data set. I think you mentioned those are add-ons. Maybe maybe just give an overview of some of the options there.
Mm-hmm. Yes, absolutely. The TomTom and Geocoding dataset are part of the spatial data bundle, and that is an add-on for the basic Alteryx. You can go to the Alteryx.com website and then click on products and then pricing, and you can see that the spatial bundle is an add-on there for additional pricing. It is really worth it to be able to use this geocoding option and the CAS options to clean and standardize your data. I've actually used these options for many years, and when I was in the retail industry, I could geocode about 1 million records in 20 minutes. It was incredible. Again, that was 20 minutes. I can geocode 1 million records. And I was using CAS to standardize and clean while that geocoding was going on. So my accuracy was getting up into the 95 percentiles there for accuracy after cleaning and standardizing those addresses. So, and that was just one use of it. The TomTom data also allow you to do drive time trade areas and drive time distance analyses.
All right, thanks. There's also a question here from Jim. If you have the from and to in your data and you want to geocode through TomTom, can you get the mileage between those 2 points as something that it would return?
You can, absolutely. I'm going to click over here just to show you quickly. That would be in your spatial tool set here, and you would use your distance tool. So it will actually calculate distance. I'm going to actually just click it here so you can actually see some data for the point source. But you can output not only straight line distance, but you can output drive time and distance to the nearest centroid using not only off-peak times, but night and peak or rush hour times. So again, this is very useful, very flexible. You also get your cardinal direction and your direction in degrees, and you have a lot of options for your units as well. So again, that drive time option comes with that additional spatial data bundle.
All right, thanks. And then this one goes back to one of the examples you were showing. There's a question about why there were so many null census tract IDs in the results set.
Yes, for some of these census tract IDs, these nulls here, let's see, was it probably this one? It probably found most of these census IDs. But then there were some that I think came out where there weren't census IDs that were not matched. And that was a very good question because it turns out when you're researching your census IDs, let's see if I can find some of those. This one isn't showing too well. If it didn't find it according to the block groups that I selected, I only selected block groups for Massachusetts, and it turns out a lot of this data is in Rhode Island. So that's one of the reasons it didn't find those. Another one is if it geocodes only to the zip code level, it will only find the census ID down to the county level. So let's see if I can get an example of that here. For the zip9, it will find the census ID, but I don't show an example. But again, if it zip codes only to the zip5 level, it will only do those first 5 digits of your census ID, 2 digits for state, and then the next 3 are county.
All right, thank you. The last question is from Jorge, and it is, will there be a recording? And so the answer is yes. I believe we've captured a recording, and we'll clean that up a little bit and then post it out there. I am even now sending a link to everyone where these videos end up. We are working through the process of trying to make sure that everyone gets notified when those videos get up there. I don't know that we've quite nailed that process down yet, so I apologize, but you may have to check back a few times to see when that video shows up, but it's usually a day or two after the webinar itself. And in the meantime, you can look at the archives there. There are a lot of videos from previous webinars, as well as just some shorter tips and tricks videos. Everything from Alteryx to Tableau, and even now some Wearescape and some Data Robot for the AI and predictive. So all kinds of really interesting things that you can find there. Dina, any last words or thoughts?
The only thing I can think of is if you do have questions or need assistance with your data, especially customer or hospital patient data, or really any address data, we'd be very glad to help. Again, we have certified Alteryx experts here at Technion, and then I definitely am certified in GIS as well. And we'd be very glad to help you find those answers and dig deeper into your address data. So thank you all again, and again, have a great weekend, and may the 4th be with you.